All right, so determinism. A bunch of stuff like what we call a galaxy, a solar system, or a car, or a mouse, or anything that can be an object of thought, any physical stuff. Is deterministic if its state at any given time depends precisely on its immediately preceding state. The state it's in now depends on the state it was just in. And the state it was just in depended on the state that it was in before that. State at t0. T0 means just sort of starting time. Determines state at t1, which means the time immediately after that. So if you can think of the smallest possible interval of time, the two states of a system being as close together as possible in time, right? The state that the first one is t0, the second one's t1, and t1 is followed by t2, by t3, by t4. It's basically how the state is now was caused, how the system is now was caused by how it just was immediately before. And that state was caused by the one before that, and that one was caused by the one before that, and so on, all the way back to the beginning of time. One way of looking at this, one way of looking at this is thinking about this is just a statement of the laws of nature, just a statement that says nature follows laws. Nature follows laws. The idea of determinism. If I say that the universe is deterministic, I am saying that all of nature, all of the universe follows laws. That the laws of physics are actual laws that control the way the universe is, or at least describe the way the universe will be. It won't be different. Another way to illustrate this is to imagine that a universe exactly like ours exists in some alternate reality, and the universe is exactly like ours, and all the laws of nature are the same, and the universe's starting condition is exactly the same as our universe. If there was such a universe that was exactly like ours, and when I say exactly, I mean absolutely exactly, down to the last vibration of the last electron circling the last hydrogen atom. Actually, down to the condition of the last quark. I heard on a podcast today that quarks are believed to be indivisible, which means that the way that people thought atoms, used to think atoms were, that there's something that cannot be broken down any smaller. And I'm like, finally. Right? When I was a little kid, I heard about them splitting the atom. It's like, I thought atoms weren't supposed to be splittable. And then they split the atom and they get neutrons, and they found out neutrons can be split. Right? Protons break down. Right? But quarks, I mean, the quarks are the bits that are left. But But so right down to the last condition of the last quark, everything's absolutely identical at the starting condition. Well, what that means is, if that universe started at the exact same instant that our universe started, it would have developed in the same way. It would have had the same history. It would have, everything would have happened the same, exactly the same set of events. Which means if that universe exists, in it there is a classroom exactly like this, with a teacher exactly like me saying exactly the same things to a group of students that's exactly like you. Everything's caused. And the way things are, well, another way of putting it, everything happens for a reason. Right? There are no things that happen in people's lives that weren't caused. Now, usually when it says everything happens for a reason, it means God wants you to be miserable or something like that, or live in Minnesota or something like, you know, God wanted this to happen. But there's another way of interpreting it. It says, look, everything happens to a reason means nothing happens without a cause. Right? If someone gets sick, there's a cause. It may not be a cause we can trace or understand right now, but we can figure out how it works. It goes back to, of course, there's no such thing as magic. Everything works by deterministic laws of nature. And that's what determinism says. So that's the definition of determinism.
Is it like the chaos theory or the butterfly effect?
Those are consequences of determinism in very complex systems.
Okay.
Right? The butterfly effect is the idea of sensitive dependence on initial conditions, which means that sometimes an avalanche could be just waiting to happen. Well, let's put it this way. Let's say there's a hillside and the hillside is soaked with water. Right? So this is water. This is soil soaked with water. Right? Now let's say there's a hiker. I can't see he's a hiker because he's got a stick. And he's hiking up here. Now, if the hiker he goes up to the top of the hill and he decides to stand on the reverse slope and look. And let's just assume that it's possible that he stands in one of two positions. Well, there's a couple of places that he can stand. He could stand at the red spot, or he could stand at the green spot. And the red spot and the green spot are right next to each other. So let's imagine that he's standing on the green spot. Stick. Does that look like a hiker with a stick? Okay. He's got his head looking at the view, and he stands there for 15 seconds, and then he walks on. Now, if he had stood on the red spot, the ground would have given way beneath him, and this whole hillside would have come down and flooded, charged into the valley, and it would have destroyed this very nice little church, this village.
What year was that?
Right, this little enormous cat came up bigger than I thought. Right, so there's a cat or some kind of mutant monster down there. And everyone dies and is destroyed. But because he stood 6 inches further up the hill, everyone survives. The hillside eventually drains out, and they never have rain like that again, and they never know how close they were to dying because they didn't know the situation. Right? And sensitive dependence on initial conditions says that in various things, that heat can build up in the atmosphere, and a breeze from the wrong direction could turn that into a really devastating weather system. Or the breeze could go the other way and it just cools down again. Have you ever got to a pot just before it boils over and turn the heat down? Right? Or have you ever been carrying something very valuable and fragile that would have had huge, horrible consequences? Or have you ever almost gone off the road? Right? That's the sensitive dependence thing. If you'd stayed dozing a few seconds longer on that trip, death and destruction. Let's say you're driving a school bus full of, politicians, and then there has to be elections everywhere, and then there's a war. Right? And there's all kinds of things that happen in the universe that have sensitive dependence on initial conditions. Right, which is why the universe is largely unpredictable, even though it's deterministic. Now, think about this situation again. What determinism says is if we were able to wind back time, right, to the morning when the hiker sets out, it would go exactly the same way. He would almost destroy the village, but then not quite. And it would happen again and again and again and again. If you read the Hell Mountain story, right, this is the same theme. Same conditions, same result. Same conditions, same result. As long as the conditions are exactly the same, down to the last color or last vibration of position of the last quark, right, if anything's even slightly different, well, if anything's even slightly different, it could make an enormously different result in the end. There's numerous cases, if you study aviation history, there are numerous cases of airplanes getting lost or destroyed or because they had a very small deviation in the compass, and they thought they were going north by northwest, and they were actually going northwest. I don't know, something like that. A couple of points of the compass either way. You can miss your landmarks and bang, you're dead. That's why aerial navigation is so tricky. Now they have like LORAN and stuff like that, so it's a lot easier. And GPS. GPS makes it easy. Pretty soon airplanes will be self-piloting. So that's the thing about determinism, is that the state of the universe right now, as long as there was no interference from outside, was determined by the state of the universe 100 years ago. But you've got to remember, it's stepwise determinism. Determinism is not the same as fate or predestination or anything like that. Our names are not written. Determinism does not say that our names are written in a book of fate. It doesn't say that we're going to it doesn't say that we will necessarily die on a certain day and there's nothing we can do to avoid it. It just says that what happens in the next second is determined by the state of the universe in this second. Do you see the difference? Right. So it's not set, but when I have people do the determinism and free will paper, and they'll say, well, if everything's predetermined, it's like nobody says everything is predetermined. Some people say that determinism is true, but determinism doesn't say everything is predetermined. Right? It's not preordained. If the causality goes one way, that's the way it goes. There's no pre-choice. Okay, so there's a definition of determinism. Almost all the laws of, well, actually the laws of nature, well, where we can completely describe a system, the laws of nature are deterministic. Some laws of nature contain unknown things. We don't know what's going on. So, let me see about that. But the thing to remember is where determinism is absent, things are truly random. Indeterminism is true randomness, full randomness, complete randomness. Indeterminism is true randomness. I want to explain. Well, in an indeterministic, when an indeterministic condition, the state of a group of objects at any given time does not determine what will happen next. I'll give you a sort of example. By the way, whenever I think about indeterminism, in anything like a macro level, anything above the subatomic level, everything above quantum mechanics, it's sort of mind-bending. But let's see what indeterminism would be like in real life. And you can tell me if you've ever experienced anything like this also. So you get in your car to drive home, and you merge on the freeway, and there's a semi-trailer coming up very, very fast behind you. No problem. You decide you're going to turn the wheel a little to the right. You know, you've checked the lane, a little to the right, and you want to get into that nice, empty, safe right lane next to you and let the semi-trailer go past. But, unknown to you, magically, indeterminism has gotten into your steering system. So turning the wheel to the right a little bit makes your windshield wipers come on. So you try again, and your trunk opens. And you try again, and a cup of coffee appears in your glove compartment. And you try again, and it's too late, the semis hit you. But, right. But that's how indeterminism works. Indeterminism is, I try to make something happen, and doing what worked last time doesn't work this time. So think about anything that you've ever done that relies on you following a certain set of steps, i.e. everything you've ever done. Cooking. You know, I like to cook chicken piccata, and I take a certain set of steps. Suppose every time I do this set of steps, every time I've done this set of steps up to now, if I've done them exactly the same way I did before, I get the same dish. Right? This time I take chicken cutlets and, take chicken breasts, butterfly them, dredge them in, pound them, dredge the cutlets in flour, fry them, wine, butter, lemon, whatever, capers. Right? And I do everything the same, and I end up with a dead fish. And not a particularly nice dead fish, a really smelly dead fish. Because getting chicken together did not result in chicken piccata, it resulted in a dead fish. That's indeterminism. Right? If you think about indeterminism is when the laws of causality don't exist. Right? And we can imagine indeterminism in the sort of sense of imagining weirdness, but if you think about, is this ever actually going to happen? Well, does a computer ever turn into a ball of petunias? That's indeterminate. Indeterminism is absolutely anything can happen. And the state of a group of objects, of atoms, doesn't determine its state in the next second, in the next instant. So we don't just depend on the laws of nature for our technology to work. We depend on the laws of nature for our continued existence. Imagine if the laws of physics stopped for a second in your body. The Krebs cycle would be interrupted. The vesicle transport system would be interrupted. The flow of blood through your body would be interrupted. And the binding of atoms to other atoms to make molecules will break down, because that's part of the laws of nature, that's force binding. The binding of molecules to other molecules to make proteins. Oh no, wait, protein is a molecule. To make cell walls will break down. You collapse in a mass of undifferentiated particles. You know, you would not be you any longer. Nothing that makes you you would persist. If indeterminism happened for a second, the laws of nature would not be able to maintain your existence as the human body you are now. That's what indeterminism is. Now we can imagine very, very limited kinds of indeterminism, just affecting the steering of your car, or we can imagine really gross kinds of indeterminism. Imagine if all the neurons in your brain fired at random, that the firing of neurons was not controlled by the programs in those neurons, that whether a neuron fired or not had no relationship to the inputs to that neuron. Well, there are human beings who have a condition that's very much like that. You know what it's called? Epilepsy. Have you ever seen anyone in a grand mal seizure? That is, or a petit mal seizure. That is what it would be like if your neurons fired randomly, if your neuron firing became indeterministic. Now, if the whole neuron became indeterministic, well, the atomic bindings wouldn't work, the proteins wouldn't have together, the lipids wouldn't line up, there'd be no cell wall, there'd be no cells, your brain would be mush. Indeterminism is bad for you. We don't want it. At least I don't want it. Okay, now, so I'm going to go into this stuff, right? This the stuff that I covered in the questions, and I'm going to go through the reading. But I'm going to make a comment on what I see are the biggest problems, and I want to emphasize, of course, that what you're getting here is my opinion. In this classroom, what you get again and again and again is my opinion, what I think is true. I don't speak for the whole of philosophy, and I'm perfectly capable of making mistakes. I'm perfectly capable of misunderstanding stuff. So when I tell you that some other philosopher is a complete thundering idiot, I'm actually right, but when I tell you should always have in the back of your head that little critical thing of, well, maybe Young has made a mistake. And actually I want to say, if I do that, it is actually a red flag. Because I've seen philosophers patronize other philosophers. I've seen them mock and mock other people and be snarky about it. And almost invariably, the snarky one is the moron. The one who's snarky about other people has been the idiot. I hope that's not true in my case, but it might be. Right, so, but I enjoy snarking, so I'm going to go on with it. So I'm going to claim, and you can judge for yourself whether this claim is true or false, that there's two big problems in this area. One, knee-jerk equation of determinism and no free willism. No free willism, it's a word I made up. It means the doctrine that there's no such thing as free will, that free will does not exist. I had to make up this word because I didn't know of a word for lack of free will already existing in philosophy. Maybe there is one out there, but it did not show up in our textbook or anything else I read. So I've never come across a word for that means no free willism, so I made the word up. And I like it because it kind of sounds like what it means, right? No free willism, the idea that there's no free will, no free will. And determinism sounds like, well, determinism, the doctrine that everything's determined. And they're two different words meaning different things. Right? But the people have a knee-jerk equation, a knee-jerk reaction. Everything's determined. Oh, there's no free will. No, didn't say that. If you want to think that determinism rules out free will, you have to prove it. That is something that requires proof. Leads me to the second thing, is relentless attempts to make determinism rule out free will. Now, if I've got my reading arranged correctly, next week we will look at some attempts to make determinism rule out free will. But I'm going to try and do the easier stuff today. So, but these are what I think is problematic here is that there are arguments, there are no arguments that determinism rules out free will, and I think they're bad. I'm going to try and cover those next week. I used to think there were no arguments, because every time I saw an argument, there was a place in the argument where it basically said, if it's determined, it's not free. And I went, that doesn't work. Right. And so I'm going to try and elucidate that next week. That there's a place where they come and they say, well, in order for it to be free, this has to be true. And I go, no, it doesn't. That doesn't have to be true for us to have free will. You're making a mistake. All right. So I'm going to go back like 3,000 years. Lysippus and Democritus. All is atoms and void. Lysippus and Democritus invented something called atomic theory, which in a sort of modified form is the basis of modern particle physics. They were wrong. Well, we were wrong when we discovered what we thought were the atoms. It turns out the quarks are the indivisible bits, but Lysippus and Democritus turned out to be right. Causality operates on the particle level. Now, imagine a river rock, right? A rock that you found in the bed of a river. Okay? Now, it looks like a sort of a homogeneous thing. But in that rock, there are billions and billions and billions of atoms. And each one has its own structure, and it has electrons in orbitals. And it's doing its own little thing in there, its own little business. And they're all moving back and forth. If they weren't moving, the rock would be at absolute zero, and it would destroy your hands if you were holding it, because it would be so cold it'd take all the heat out of them. And if you managed to drop it in before you lost your hands, it would shatter on the ground. Right, so the rock is not at absolute zero. So the particles then are moving back and forth. And they're moving in certain particular ways. Now imagine, oh, I don't know, what are those things that were the tether ball? Right, well imagine we take a tether ball and we ram the rod into the wall there, so the ball is here, and it's on elastic or something. And imagine somebody takes a swing at the ball and it moves, right? Moves back and forth and around and something like that. Now, depending on how it's released and with what force, it'll move differently. And in fact, there's infinitely many different ways that it can move. Well, the same is true of every little atom in a rock, and they're all moving different ways. And the ways they are moving depends actually on that rock's history of being banged by other rocks as it rolls down, and so on. Right. There's this. There used to be this British TV show called Primeval, in which dinosaurs had come through time gates and terrorized modern England. It was pretty cool, especially near the end. They really hit their stride. People used to worry about killing a dinosaur. A dinosaur didn't go back, and it would change history. First, the time gates are historical artifacts. They exist in history, so whatever change you've made has already happened. Second, suppose you could enter a universe, right? Enter another universe, and you can move through time. So you see, there's this big civilization there, and you say, I want to mess with that civilization, and I'll go back 1 billion years, and I'll kill a dinosaur, and that'll mess them up. And you go and you kill a dinosaur that would otherwise have lived, and you think, aha, everything will be different now. And you go back there, and nothing's different that you can see. But if you could see the little vibrations of the atoms in the concrete walls and in people's cups of coffee and other things like that, you would see some of them are moving differently than the way they were before, right? A carbon atom in somebody's mustache hair is going like this instead of like this. Okay. All the changes.
Sorry, I didn't get that.
All the lots of change, but nothing we notice on the human level. And we think that causality operates on big things like us. Well, it doesn't. The only way causality affects big things like us is because we are made of little things. We're made of quarks and possibly protons. I'm not really sure. We're made of quarks and protons and stuff. And those things affect each other. And so when I put my hands together like this, the reason they don't pass through each other, right, the reason is because they're made of atoms, and those atoms are bound together by forces which are mediated by particles, fermions, and so they can't interpenetrate because there's a force mesh there. Right? But it's all causality is atoms interacting with other atoms, particles interacting with other particles. Right? Everything else is sort of an emergent structure. So, causality operates at the particle level. All history is determined. And these guys figured this out 3,000 years ago. Okay, to hold back, we're made of atoms. Holbach figured out, realized, human beings made of atoms, so we're determined. Apparently, de Holbach also jumped from this conclusion to the idea that there's no free will. But I'm not going to take that jump with him. He was wrong to make that jump. He thinks that being determined magically means that there's no free will. That's something you need an argument from. I'm going to make a little picture. Okay, so here's what I call the incompatibilism gap. Most of the arguments, most of the claims that determinism rules out free will have been offered with this box in the middle empty. I got this idea from South Park. Have you ever seen the Tweak episode with the underpants gnomes? They have a business plan. Collect underpants. Question mark. Profit. And most of the time when people talk about determinism and free will, it's determinism. Profit. No free will. It's a gap. This has to be filled by something. So next week, plan to look at some efforts to fill this gap and make determinism rule out free will, and we'll try and see how well those arguments work out. All right, Pierre-Simon Laplace, marvelous mathematician. He realized something, but this is something that's realized only in principle. It's something that could never be practical. It could never be technically feasible. This is Laplace. Talks about Laplace's demon. I think that's a bad way of talking about it. I want to talk about Laplace's if. As you can see, it's a big if. And you have to remember that this, actually Laplace's if is a if big enough to be seen from space in another galaxy. It's that big. It's big. In fact, it's insurmountably big. If we knew all the vectors, you guys know what a vector is? In mathematics, technically, it's a string of numbers. In physics, a vector is the motion of an object. It's its direction and its velocity. So if we knew all the vectors of all the particles, and I'm talking about quarks and photons and protons and neutrinos and whatever dark matter is made of and whatever the mediating particle is for dark energy, all of them. So we knew all the vertical vectors of all the particles in the universe at a single instant, because if we measure one and then we go over here and measure another, that one's changed, and then now it's different. So you have to measure them both at once. In fact, you have to measure all the particles of all the universe all at once. You begin to see the problem. Right. At a single instant, and had full exact knowledge of all the laws of nature, and we don't have this. We don't have full exact knowledge of all the laws of nature. They just verified this year, verified the Higgs boson. Higgs and another guy got the Nobel Prize for it. And we now, they now have some idea of how most particles get mass. Apparently not neutrinos. Neutrinos don't have a Higgs interaction. I have no idea what that means, but the Higgs particle gives protons their mass, neutrons their mass, electrons their mass, but it doesn't get around to neutrinos. Something else does that. We need more funding. So if we had exact knowledge of the laws of nature, we could predict all the future and retrodict. That means in the past, dict in the past. All of the past. Now, online, I think linked to one of my pages, there's an online orrery, which is a picture, a visual model of the solar system in action. And you can set it to any date in history over a very wide range, and it'll show you where all the planets were relative to each other and the sun at any time in history. And we can do this because planets are relatively big things, and the things around planets, like asteroids, have relatively little effect on them. Right? And we have Newton's laws of motion. Now, the problem is, right, the solar system is not perfect. It's not empty except for the planets. And the mathematics is really hard. So, spaceships carry fuel. They need it to adjust their orbits when they get closer to other bodies. So when you send a space probe out, every so often it'll make a course correction, because there are influences on its course that we don't know about. And you know that thing about getting a millionth of a degree of arc over 1 billion miles, right? You make this very small error. That can put a spaceship really out of position. So they have to be, every so often, a course adjustment. They have to plan course adjustments because they know it's going to be out of position. So we can make predictions about the solar system into the future, and we can retrodict it in the past and tell where the planets were. But the further back we go, the less accurate it will be. The further forward we go, the less accurate it will be. Because the planets are not just affected by each other's gravity, they're affected by the gravity of the asteroids. Every body in the solar system interacts with every other body in the solar system. Objects the size of a tennis ball have a gravitational effect on Jupiter and a really, really tiny effect on its orbit. So we cannot really precisely do this for something that's as relatively simple as the solar system. When you look at stuff like human beings, we're much more complicated and much more sensitive to sensitive to initial conditions, sensitive to our conditions. Lots of things affect us. The, sugar levels, right? So you can get violent. So if we had, yeah, sure, if we knew all the vectors of all the particles in the universe as a single instance and had exact knowledge of the laws of nature, we could predict all the future and retrodict all the past. But that's a big if. It's an infinitely big if. I can't tell you precisely how long this pen is. I can maybe do it if I had, calipers, and right, I could do it to, say, 1/1000th of an inch, but to 1/1000th of an inch, no. And 1/1000th of an inch is not really very high precision for this stuff. You have to know the positions exactly. We can't know the positions exactly. And we have to know the positions of the particles in the computer or notebook or whatever it is that we're storing this information. It says all the particles. Not some of the particles, all the particles.
Well, it deals with absolutes.
Yeah, it deals with absolutes. And so, here's the kicker. Yeah, this is actually turns out to be completely unhelpful. Right. And it makes a difference between, so there's a difference between determinism and predictability. The weather is a deterministic system. We know it's a deterministic system. There's no quantum mechanical effects that affect the weather, even if quantum mechanics has indeterminism. There's no quantum mechanical effects that affect the weather. It's masses of air particles, gases, heating from the sun, electrical flux from the sun, cosmic rays, a little bit, ultraviolet radiation, changes in the chemical composition of the ozone layer, greenhouse gases, a variety of other gases can have effects. So, how far ahead can we predict the weather?
To within a week.
Yeah, a week.
5 days.
Yeah, about 5 days. Is it always right?
No.
No. After 5 days, we start again. We run our algorithms again. The best predictor of the weather is that the weather today will probably be pretty much like the weather this time last year, because the planet was in the same position relative to the sun. But that's it, and it's not a very good predictor. All right, determinism, actually, deterministic systems are generally too complicated to predict. Now you mentioned chaos theory, or I should say chaos studies. It's not really a theory. There is no chaos theory. Chaos studies is really the study of nonlinear mathematics. Now, there are a lot of nonlinear systems. My favorite nonlinear system is a faucet. Did I do this one before?
The faucet,
Yeah, the faucet, right?
drop of water.
Yeah, the drop of water. Here's your faucet. I use blue for water. I've got blue one. Right.
The tap. as you called it.
Yes, the tap. Okay, think about slow motion photographs of a drop breaking away. It's a deterministic system. When the drop breaks, right, with the tap, you've got a continuous flow of water to here. This is continuous, steady, invariant flow. And here we have variable. Variable flow. Right. Why is this? Why, by the way, if you have, remember, take a faucet, turn it so there's a continuous stream of water, then slowly close it down until the stream of water gets thinner and thinner until suddenly, near the bottom of the stream, it breaks into droplets. Why does it break into droplets? Why doesn't it stay continuously until it's one long chain of water molecules? Because of surface tension, because the water molecules attract each other very strongly. And when you have your continuous stream, oh, by the way, also, it gets thinner as it goes down. Right, oops, like that. And at a certain point, when it's like really thin, it can't stay that thin because the water is attracting itself together and it breaks here and makes a droplet. Right, so it's pulling itself into smaller bits. And this is actually a process where molecules pull themselves together to make these organized things. Like, you ever seen the Devil's Postpile, or the Giant's Causeway in Ireland? These hexagonal posts of basalt. It's because it was cooling. It's cooling over a long time evenly, and it was pretty set, and then it shrank, and it pulled, the molecules pulled themselves together. They were no longer hot enough to be expanded, so they pulled apart and they contracted, and it meant it pulled apart on these regular things. It's called symmetry breaking. That a little crack somewhere means that these two bits move apart, which relieves pressure here and creates pressure over there, so that the hexagonal pattern will spread out from a starting point. Anyway, you've got a steady invariant flow here and then a variable flow here, because you have the molecule pulling on each other to try and make these little spheres. Right? So what happens is the water builds up here, and then it gets too heavy to sustain itself, and then it falls. But the period between each drop changes every time. You never get one drop a second. If you have two that are a second apart, the next one will be more or less than a second. And you can't predict it. It's a deterministic system, but you can't predict it. Because there's stuff going on in here, right? Every time this goes down, it breaks in a different place because the molecules are moving, right? They're not organized. They're moving in random directions. And sometimes the way they're moving means that it'll break earlier or later. Right? And when it breaks, it leaves that will determine whether it leaves behind a lot of water or just a little water. How much does this take with it? Well, it depends on turbulence in this thing. This cannot stop being turbulent because the water is coming out and it's spreading into this and it's circulating. You know, if you take what looks like a still pan of water, all the water in there is moving. You can't see it. It's not moving enough to make big ripples, but the water is circulating slowly and it's turning over. So you get this system that's where you cannot predict when the next drop will come, only that there will be one within a certain period of time, because you know this gross fact about it, that it can't build up forever. So, determinism does not imply predictability. Predictability is the human ability to tell what's going to happen next. Determinism is the laws of nature determine what's going to happen next. But that doesn't mean it's predictable. We usually don't know enough about the system to know how it's going to work. There's always something going on that we don't know about. Have you ever had your car break down unexpectedly? Ever heard of that? Right. Now, as far as you know, your car shouldn't break down because, as far as you know, everything's in working order. You didn't know that a hose was rotting out. I didn't know that my electrical system was rotting out in my car. And so my car didn't work anymore. And the guy I took it to didn't know that it was the electric side. He thought it was the fuel system. Then you finally checked the electric. Why the hell didn't you check the electric? Well, you said it was the fuel. Well, I'm not a mechanic. You're supposed to check the fuel system, but also check other things. Right. So something's going on that I don't know about means I can't predict what's going to happen. Ginger. So determinism does not imply predictability. Now, can you get predictability without determinism? If a set of events is truly random, can you tell what's going to happen next? Right, so if you see a system that does have some predictability, like a fellow who you know is going to go to church, who routinely goes to church, so you know he's going to go to church next time, or he's at least very probable that he's going to go to church next time, or you can predict that at least 50 out of the next 52 Sundays he'll go to church. Right. Predictability implies determinism. Indeterministic systems are not at all predictable. They cannot be predictable. Knowing the state of the system at time t doesn't tell you anything about what's going to happen next because the state of the system does not determine what will happen next. Okay, how about we break and come back at 8:30?